Hello student, I am Dr. Khushboo Verma and today I am going to discuss about Laplace transformation. Before this, we should know about the application part of this transformation. With the help of this transformation, we can convert any function ft defined over a positive variable t into a complex function which is defined over a complex variable. Laplace transformation, or we can say Laplace operator, is denoted by capital A. When this operator operate on any function ft which is defined over a positive variable t, we will get the integration which is defined over 0 to infinity e raised to power minus st ft dt. Here integration is taken with respect to t only, and this variable s is a complex variable. After solving this integrand, we always get the function which is of the form of s. That means when we operate this Laplace transformation over a function which is defined over a t, we always get a function which is defined over a complex variable s. Now let us see Laplace transformation of some special function like 1 t raised to power n e raised to power at cos at sin hyperbolic at and sin cos hyperbolic at. Okay, Laplace transformation of 1 is what? With the help of this formula, Laplace transformation of 1 is 0 to infinity e raised to power minus st into 1 dt. With the help of this formula, ft is 1 here, and that's why this ft is again replaced by 1 here. 0 to infinity e raised to power st into 1 dt. Now solving this, after solving this integration, we will get 1 upon s, where s should be greater than 0. If this s is less than 0, that means if this s is a negative quantity, then e raised to power minus into this negative quantity become positive quantity, and after putting this infinite here, we will get e raised to power infinity, and resultant the value of this integration we will get the infinite here. That means Laplace transformation in that case is equal to infinite, which is not allowed here. That's why s is greater than 0 here. Similarly, Laplace transformation of t raised to power n is what? With the help of this formula, in this case ft is equals to t raised to power n. That's why 0 to infinity e raised to power minus st, and ft is replaced by t raised to power n here, and dt. Now take st is equals to k, we will get dt is equals to dk upon s. Now replace this st by k and t by k by s, we will get 0 to infinity e raised to power minus k raised to power n upon s raised to power n, and dt is replaced by dk by s. As integration is taken with respect to k here, that's why this s raised to power n plus 1 is constant here. We can take it outside from the integration. 0 to infinity e raised to power minus k raised to power n dk. This is the well known formula of gamma n plus 1. That's why we replace this function by gamma n plus 1 upon s raised to power n plus 1, where n is defined from 0, 1 to up to so on. This gamma n plus 1 is again replaced by factorial n upon s raised to power n plus 1. Similarly, we can find the Laplace transformation of e raised to power at, cos at, and up to so on. These are the formula for the Laplace transformation. With the help of these formula, we can get the Laplace transformation of other function also. Now Laplace transformation, there are some other important formula. With the help of those formula, we can get the Laplace transformation of the function which is multiplied by the other function. First is shifting property. According to this, if Laplace transformation of ft is equals to something function of s, then Laplace transformation of e raised to power a2 into ft is equals to function of s minus a. That means in that case s is replaced by s minus a, where a is e raised to power at. Okay, let's see some question on based on this. Shifting property. We have to find the Laplace transformation of e raised to power 2t sin t. Laplace transformation of sin t is we know, but e raised to power 2t into sin t, we don't know the Laplace transformation of this. Here with respect to apply this shifting property on this question, here we have to find what is ft here. Ft is sin t and multiply by e raised to power 2t. Now Laplace transformation of sin t is what? With the help of this formula, sin t is where a is equals to 1, replaced by a is replaced by 1 is 1 upon s square plus a 1. That means 1 upon s square plus 1. Now Laplace transformation of ft is equals to 1 upon s square plus 1, that is equals to fs here. Now Laplace transformation of e raised to power 2t into sine t is equal to function of s minus 2, that means each s is replaced by s minus 2. That means the answer is 1 upon s minus 2 whole square plus 1. Okay. Similarly, Laplace transformation of e raised to power minus t cos hyperbolic 2 is what? With the help of this shifting property, this is ft here. Ft is cos hyperbolic 2t. Laplace transformation of this ft is with the help of this formula cos hyperbolic 8 is s upon s square minus a square. Here a is equals to 2, that means s upon s square plus 2 square, that means s upon s square minus 2 square, that is s upon s square minus 4. Now Laplace transformation by shifting property, t into cos hyperbolic 2t is equal to, that means is equal to s of s minus a is equals to minus 1, that means minus minus plus 1, that is s plus 1. That means in each s is replaced by s plus 1. In that case, s is replaced by s plus 1 whole square minus 4, that is the answer. Okay. Now Laplace transformation of the integral. According to this rule, if Laplace transformation of ft is equals to fs, then Laplace transformation of 0 to t ft dt is equals to fs upon s. Let's solve some question based on this. Laplace transformation of 0 to t e raised to power minus t sine 2t dt. We can solve this question manually, but time is matter here. With the help of this Laplace transformation of integral, we can solve it easily. First, when we apply this formula on this, then what is ft here? Ft is e raised to power minus t sine 2t, and we have to find the Laplace transformation of this. Laplace transformation of e raised to power minus t sine 2t, this, and Laplace transformation of this function can be obtained from by the shifting property. Before this, we have to know Laplace transformation of this. Laplace transformation of sine 2t is what? 2 upon s square plus 2 square, that is 2 upon s square plus 4. Now Laplace transformation of e raised to power minus t sine 2t by shifting property is each s is replaced by s plus 1, that means 2 upon s plus 1 whole square plus 4. Again, this is equal to fs here, Laplace transformation of integral case. Now Laplace transformation of 0 to t e raised to power minus t sine 2t dt is equal to what? That is f of s upon s. Here fs is equals to what? 2 upon s plus 1 whole square plus 4 upon s, that is equals to 2 upon s plus 1 whole square plus 4. Okay. Let's solve this second question. Laplace transformation of 0 to t e raised to power 2t cos t dt. Here integration, that means Laplace transformation of integral. In this case, this become ft here. F of t is what? 0 to t e raised to power 2t cos t dt. Okay. Now again we have to find Laplace transformation of this. Here again apply Laplace transformation of integral on this, and for this again this become ft here. Let this is f1 and this become f2. Now Laplace transformation of e raised to power 2t cos t is what? Laplace transformation of e raised to power 2t cos t is what? With the help of shifting property. First we know the Laplace transformation of cos t. Laplace transformation of cos t is what? S upon s square plus 1. And now operating shifting property on this, we will get the Laplace transformation of this, that is s plus minus 2 upon s minus 2 whole square plus 1. S minus 2 whole square plus 1. Now Laplace transformation of 0 to t e raised to power 2t cos t dt is equals to what? Fs upon s, that is s minus 2 upon s minus 2 whole square plus 1 upon s, that is s minus 2 upon s into s minus 2 whole square plus 1. Similarly, Laplace transformation of 0 to t e raised to power 2t cos t dt. Again one more integration, that means fs upon s, that is s minus 2 upon s into s minus 2 whole square plus 1 and upon s, that is equal to s minus 2 upon s square s minus 2 whole square plus 1. That is the answer. Similarly, Laplace transformation of e raised to power minus t into t sin 2t. To solve this, we have to combine two property, Laplace transformation shifting property and and this property, Laplace transformation of, if Laplace transformation of ft is equals to fs, then Laplace transformation of t raised to power n into ft is equals to minus 1 raised to power n nth derivative of fs with respect to s. Laplace transformation of sin 2t is what? 2 upon s square plus 2 square, that means 2 upon s square plus 4. Laplace transformation of t sin 2t with the help of this formula. Here t raised to power 1, that means minus 1 raised to power 1 first derivative of fs, that means minus 1 raised to power n d by ds of f of s. This is equals to f of s here, and this is become minus 1 d by ds of 2 upon s square plus 4, and this is equals to minus integration of this is what? S square plus 4 into 0 minus 2 into 2s. Okay, 2 into 2s upon s square plus 4 whole square, and this is equals to what? After solving this, we will get 4s upon s square plus 4 whole square. Now Laplace transformation of e raised to power minus t into t sin 2t is what? Again operating shifting property on this become ft for shifting property, and Laplace transformation of this t sin 2t is equals to 4s upon s square plus 4 whole square. This become fs for this shifting property, and that means each s is replaced by s minus a. Here a is equals to minus 1, that means minus minus plus 1, that means each s in this is replaced by s plus 1, and this is equals to 4s plus 1 upon s plus 1 whole square plus 4 of this whole square. This is the answer. That means you have to break to find the Laplace transformation of this function. You have to break into three parts. First you have to find the Laplace transformation of this, then Laplace transformation of t into sin 2t, and then operate shifting property on this, and you will get the answer. And last property is if Laplace transformation of ft is equals to fs, then Laplace transformation of ft upon t is equals to s to integration s to infinity fs ds. With the help of this property, we can find the Laplace transformation in which we have denominator part in form of t. That means, like this question, Laplace transformation of cos at minus cos bt upon t. Laplace here ft is, if we compare this function, then ft is what? Cos at minus cos bt, that is the numerator part. Laplace transformation of this is what? S upon s square plus a square minus s upon s square plus b square. And Laplace transformation of this cos at minus cos bt upon t with respect to this formula is what? Integration s to infinity s upon s plus s square plus a square minus s upon s square plus b square ds. And after integrating this, we will get the log s square plus a square upon s square plus b square. Limit is s to infinity, and after putting this limit, we get the answer log s square plus b square upon s square plus a square, where power is 1 by 2. This is all about the Laplace transformation of the function. With the help of these properties, we can find the Laplace transformation almost all functions. Okay. Now, come to the inverse of the Laplace transformation function. The rule of the inverse Laplace transformation same as a Laplace transformation. All property which we use to find the Laplace transformation is usable to find the inverse Laplace transformation. Like if Laplace transformation of ft is equals to fs, then Laplace transformation of the integral 0 to t is equals to fs, then fs upon fs, then inverse of the fs